Hi friends, in last 3 lectures we have covered basics, evolution history of AI and types of artificial intelligence systems based on their functionalities and stages of intelligence. In this tutorial we are going to cover domains of AI, or you can say different approaches by which we can achieve artificial intelligence. There are various methods which can be used in developing an artificially intelligent system. Broadly, we categorize these methods or approaches into following categories: machine learning, deep learning, natural language processing, robotics, expert systems, fuzzy logic. Let us begin our discussion with one of the very popular and most used technology, machine learning. Machine learning has drastically transformed IT industry. Machine learning is the most popular technique to build AI systems across the globe. It gives computers or machines ability to learn without explicitly programming them to perform tasks. What do we mean by explicit programming here? Explicit programming is the manual way to consider the required changes by giving the machines explicit instruction. In machine learning, trained model or algorithm implicitly takes care of new instances or new scenarios. Machine learning or ML is one of the most exciting technologies these days. As evident from its name, it gives a computer or machine that level of ability which makes it more similar to humans, the ability to learn. There are various types of machine learning algorithms, and they are typically grouped by either learning style, for example, supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, or by similarity in form or function like classification, regression, decision tree, clustering, etc. We will discuss all these techniques in detail in subsequent tutorials of this course. Regardless of any learning style or any way of functioning, all combinations of machine learning algorithms include these steps. Representation. A machine learning model can't directly see, hear, or sense input examples. Instead, we must create a representation of the data to provide the model with a useful vantage point into the data's key qualities. You can understand the term representation in this way. In order to train a model, we must choose the set of features that best represent the data. Evaluation. Training a model is first important step in machine learning, but how the model generalizes on unseen data is an equally important aspect that should be considered in every machine learning algorithm. Evaluation is a mechanism to verify the trustworthiness of an ML model, which is determined by objective or scoring function. Optimization. Optimization is the most essential aspect in designing any machine learning model. This step helps AI engineers in selecting best ML model with as low a probability of error as possible. In optimization, we define some kind of loss function or cost function with respect to that particular ML algorithm and try to minimize it. There are many cost optimization techniques like stochastic gradient descent, which we'll discuss in subsequent tutorials. Let's recall few applications that we use in our daily life which are built using machine learning. Traffic prediction is one of the major applications of machine learning. We all use GPS navigation service. While we do that, our current locations and velocities are being saved at a central server for managing traffic. This data is then used to build a map of current traffic. This helps in preventing the traffic and does congestion analysis. We know that not all vehicles are equipped with GPS. In such scenarios, machine learning helps to estimate the regions where congestion can be found on the basis of daily experiences. Rental transport business companies like Ola, Uber also use machine learning in deciding best available route or price search during peak hours. Now, let's discuss second approach to build artificially intelligent systems: deep learning and artificial neural network. Deep learning is a subset of machine learning. It is the class of machine learning algorithms that uses multiple layers to progressively extract high-level features from the raw input data. While machine learning uses simpler concepts, deep learning works with artificial neural networks which are designed to imitate how humans think and learn. Until recently, neural networks were limited by computing power and thus were limited in complexity. However, advancements in big data analytics have permitted larger, sophisticated neural networks, allowing computers to observe, learn, and react to complex situations faster than humans. Deep learning has enhanced the capability of many applications of AI like image classification, language translation, speech recognition, pattern recognition, etc. Artificial neural networks, comprising many layers, drive deep learning, or you can say deep learning is large neural networks. Large or deep neural networks are such types of networks where each layer can perform complex operations such as representation and abstraction that can make sense of images, sound, and text. Considered as the fastest growing field in machine learning, deep learning represents a truly disruptive digital technology, and it is being used by increasingly more companies across the globe to create a new business models. Let's understand deep learning using an example. Imagine a little baby whose first word is dog. The baby learns what a dog is and is not by pointing to objects and saying the word dog. The parent says, yes, this is a dog, or no, that is not a dog. As the baby continues to point to objects, he becomes more aware of the features that all dogs possess. What the baby actually does, without really knowing, he clarifies a complex abstraction, the concept of dog, by building a hierarchy in which each level of abstraction is created with the knowledge that was gained from the preceding layer of the hierarchy. Various different methods can be used to create strong deep learning models. These techniques include learning rate decay, transfer learning, training from scratch, and dropout. We will discuss about these methods later in a separate tutorial. Now let's talk about third technique which is widely used in text mining, sentiment, and emotion analysis. Natural language processing. Natural language processing, usually abbreviated as NLP, is a branch of artificial intelligence that deals with the interaction between computers and the humans using the natural language. The ultimate objective of NLP is to read, decode, understand, and make sense of the human language in a useful manner. In fact, a typical interaction between humans and machines using natural language processing can go like this. A human talks to the machine machine captures the audio, converts audio to text, processes the text data, text to audio conversion takes place. And finally, the machine responds to the human by playing the audio file. Have you ever watched the promotional video of Grammarly? It is NLP in the background which helps in checking and correcting grammatically wrong texts. Natural language processing is the driving force behind the following common applications. Language translation applications such as Google Translate. Word processors such as Microsoft Word. Interactive voice response applications used in call centers to respond to users' requests. Personal assistant applications such as Google Assistant, Siri, Cortana, and Alexa are also applications of NLP. Natural language processing is a very useful and popular technology. We will understand its principles and various models in detail in a separate tutorial dedicated only to NLP. Now let's understand another technique to build AI systems. Robotics. Robotics is a domain in artificial intelligence which deals in creating intelligent and efficient robots. Robots are the artificial agents which act in real-world environment. Robots are aimed at manipulating the objects by perceiving, picking, moving, modifying the physical properties of objects. Robots are built to free human power from doing repetitive functions without getting bored, distracted, or exhausted. In addition to having mechanical construction, electrical components, form or shape designed to accomplish a particular task, robots contain some level of computer program that determines what, when, and how a robot executes something. For example, Kismet, a robot at MIT's Artificial Intelligence Lab, recognizes human body language and voice inflection and responds appropriately. Kismet's creators are interested in how humans and babies interact, based only on tone of speech visual cue. This low-level interaction can become the foundation of a human-like learning system. Now let's talk about another method, that is rule-based expert systems. An expert system is an interactive and reliable computer-based decision-making system, which uses both facts and heuristics to solve complex decision-making problems. It is a computer application which solves the issue of a specific domain. The expert system can resolve many issues which generally would require a human expert. It is based on knowledge acquired from an expert. It is also capable of expressing and reasoning about some particular domain of knowledge. Expert systems were the predecessor of the current day artificial intelligence, deep learning, and machine learning systems. Eliza, the first chatbot which we discussed in the last tutorial, is also an example of expert systems. There are few fundamental key points which every rule-based system holds, like it emulates decision of an expert. It utilizes set of facts. It validates a set of rules. Manual handling of new unseen cases. It is deterministic in nature, not like machine learning models which are probabilistic in nature. Rule-based systems are quicker, but they can become bulky while solving a complex problem, which can have a lengthy chain of rules. Now let's discuss another technique to make a machine artificially intelligent. Fuzzy logic. Fuzzy logic is a method of reasoning that resembles human reasoning. The approach of fuzzy logic imitates the way of decision making in humans that involves all intermediate possibilities between digital values yes and no. What a human brain does when stuck in a confusing situation. It tries to decode the situation which contains incomplete vague facts or previous experience. Similarly, fuzzy logic systems produce definite output in response to an incomplete, ambiguous, distorted, or inaccurate input. The conventional logic block that a computer can understand takes precise input and produces a defined output as true or false, which is equivalent to humans' yes or no. For example, anti-lock brakes are application of fuzzy logic which control brakes in hazardous cases depending upon car speed, acceleration, wheel speed, and acceleration. Auto injection of fuel and ignition based on throttle setting are examples of fuzzy logic systems only. Thanks for watching the tutorial. Hope it would have informed you about the ways or techniques used in developing artificially intelligent systems. With the end of this tutorial and including last 3 tutorials, we have covered theoretical literature of artificially intelligence like its evolution, its classification based on intelligence and functionality, and the techniques to build AI systems. From the next tutorial onwards, we'll start exploring machine learning technology, a must-require technology for AI engineers. If you have any questions or comments, please let us know in the comment section. Please like and subscribe our channel to be notified about new tutorials.